Okay, good morning guys. You will determine if a number is divisible by a certain number. So for our object, first, determine if the number is divisible by a certain number. Second, you will simplify fractions using divisibility rules. So I hope these rules will help you to simplify fractions. Let's start first with number 2. Notice, the examples are all Yes, they are all even numbers. So if a number is even, it is divisible by 2. How would you know if a number is divisible by 3? Let's have the first example. So the table will help us if the number is divisible by 3 by adding the digits. So let's have 15. The digits are 1 and 5. So 1 plus 5. The sum is 6. Do the same thing for the next numbers. 243, it is 2 plus 4 plus 3, and the sum is 9. Next number is 6 plus 7 plus 8, and the sum of this is 21. Lastly, 1059, the digits have a sum of 15. So what do you notice with the sums of the digits? 6, 9, 21, and 15, they are multiples of 3, or in short, they are divisible by 3. So it's your turn to try if it's 4761 is divisible by 3. Let's proceed now to the next item. How would you know if the number is divisible by 4? These are the examples: 4, 8, 12, 16, 20, 24, 28, and so on. What if the number is very large? You don't have to count from 4 to arrive with that certain number. So the technique is use the last two digits, 56, 80, and 72, and see if they are divisible by 4 or not. Actually, they are divisible by 4. 56 divided by 4 is 14. 80 divided by 4 is 20. And 72 divided by 4 is 18. So all these numbers are divisible by 4. What about this one? A non-example is 4022. Why is it not divisible by 4? Because the last two digits, 22, cannot be divided by 4. Next, divisible by 5. So this kind of rule is very easy. Just check if the last digit is 5 or 0, or in short, if the number ends with 5 or 0, then it is divisible by 5. Now, let's have the divisibility rule of 6. We know that the factors of 6 are 2 and 3. So, this is the way to check if the number is divisible by 6. First example, is 420 divisible by 2? Yes. How about if it's divisible by, is it divisible by 3? Yes also. So if both are true, then the number is divisible by 6. So 420 can be divided by 6. Similarly, 522 divisible by 2? Yes. The sum of the digits is 9, which is divisible by 3. Yes also. 1026, it is an even number, so divisible by 2. The sum of the digits is 9, so divisible by 3. And for the fourth number, 32,158 is an even number. The sum of the digits is 19. Is 19 divisible by 3? So it is not. Therefore, the fourth number, 32,158, is not divisible by 6. The last number is for your exercise. Try to practice and see if 123,456 is divisible by 6. Let's have the next number, divisible by 7. So first, we all know that 7, 14, 21, 35 are multiples of 7. So again, you don't need to count these multiples to arrive with 17,206. How would you know if this number is divisible by 7? So we will follow these instructions. So we need to subtract twice the units digit from the remaining digits until you have a 7 or its multiples. So the given is 17,206. The last digit is 6. So we need to multiply this by 2 and subtract it from the remaining digits, like what it is illustrated here. So multiply the last digit by 2 and subtract it from the remaining digits. So 1720, the remaining digits, minus twice the units digit, would result to 1708. So is this number divisible by 7? So we're not yet sure because it's kinda big, it's a big number. We can do again the instruction until we have a smaller number. So the last or the units digit is 8. Multiply this by 2 and subtract it from the remaining digits, 170. And the result is 154. So we can do again the steps. So the units digit is 4. Subtract it from 15. So 15 minus twice the units digit, and it will result to 7. And 7 is a multiple of 7. Therefore, 17,206 is divisible by 7. Next item is divisibility by 8. For this, you need to check the last 3 digits if it's divisible by 8. These are the examples: 1,184, 12,192, and 18,760. The last 3 digits are all divisible by 8. Next one, divisible by 9. So the technique for this, it is similar to divisibility by 3. So add the digits and find the sum. So the sum, let's add the digits, 54, 5 plus 4, and the sum is 9. Next number, 1 plus 2 plus 6, the sum is 9. Next is 7 plus 3 plus 5 plus 3, and the sum is 18. So to know if the number is divisible by 9, add the digits and determine if the sum is divisible by 9. So again, the last item is for your practice. Next, divisible by 10. Again, another easy item. Just check if the last digit is 0, then it is divisible by 10. Divisibility by 11. Here's the technique. Add the alternating digits. So if you start with 9 here, so we have 9 followed by 2. And the other alternating digit is only 0. So what is the difference of the two? For the next item, 2,695, 2 plus 9, the other pair is 6 plus 5. Next is 7 plus 2, then 8 plus 1. Next is 2 plus 9 plus 8. And the other alternating digits is 0 and 8. So adding these digits, what is the difference? 11, 0, 0, and 11. Actually, these four numbers are divisible by 11. So how would you know if it's divisible by 11? Or you may arrive with multiples of 11. Again, the last item is part of your practice. Now, divisibility or divisible by 12. The factors of 12 are 3 and 4. So how would you know if a number is divisible by 12? Using the past rules, divisible by 3, divisible by 4, you need to apply it in here. 1320. Is it divisible by 3? The sum of the digits is 6. So it is divisible by 3. How about if it's divisible by 4? The last two digits, 20, is divisible by 4. Therefore, 1320 is divisible by 12. So, here's the statements. So, for your practice, using the year of your birth in YYYY form, identify if it's divisible by 2 up to 12 and explain why or why not. Another item, using your birth date in MMDD format, the same rule. And lastly, using your birthday again, written in fractional form, can you still simplify your birth date? So I have an example for you to follow. Example, let's have the date given by Father Dindo yesterday morning. December 8, 1854. So in MMDD and YYYY, we have the following numbers. For 1854, or for the year, is it divisible by 2? The explanation, the answer is yes, and the explanation is, it is even. Is it divisible by 3? Yes, because the sum of the digits is 18, which is divisible by 3. You will do everything from 2 to 12. So dot dot dot, and the last thing is it divisible by 12? The answer is no. Although it is divisible by 3, but the last two digits, they are not divisible by 4. Again, you have three tasks. First, the given year or the year of your birth. Second, your birthday in MMDD format. Check if they are divisible by 2 up to 12. And the third task is your birth date in fractional form. Simplify if possible. Okay, have a good day. Thank you guys.